Okay, I've got another question here that's going to involve differentiation. We've got a curve, we've been told it's got one stationary point, and we have to find the coordinates of that stationary point. Let's have a go. So let's guess our curve is this red line here. And if this was our curve, this point would be the turning point, and its coordinates would have, there's the x value and there's the y value. To find that stationary point, we need to know the gradient of this curve at every point. Here the gradient is positive, and here the gradient is negative. And you won't be at all surprised that at the turning point, the gradient will be 0. That's expressed as dy dx, in other words, how y changes with respect to x, is equal to 0 at this point here. So what we need to do is differentiate our function and then equate it to 0 and find the value of x. Okay, differentiating this guy. This term's going to be easy. But this term in its current form is a little bit tricky. So the first term remains unchanged. When you've got 2 divided by x, this can be written as x to the minus 1. If you don't get that, you need to look at another tutorial where I deal with negative powers and how they can be written. So this can be written as 2x to the minus 1. So now we've got it in that form, we can apply our rules of differentiation. In other words, you grab the power, pull it down, multiply it by the existing coefficient, and then reduce the power by 1. So therefore, dy dx is equal, the first term. 2 comes down, multiplies the 8, this becomes 16, and we reduce the power of x squared by 1, creating x. And then plus. The negative 1 comes down and multiplies by the 2, so I was wrong to write a plus there. We need a negative, and this becomes x to the minus 2. So we now know the gradient function. We now know the gradient at every point on this curve now. And as I said earlier, at the stationary point, the gradient is 0. And there we've got it written down. Okay, moving the 2x to the minus 2 onto the other side, and I'm going to rewrite this as a divided by x squared term. So I get 16x is equal to 2 over x squared. Straight away, the 2 will cancel with the 16, leaving 8. And if we cross multiply the x squared underneath here, we will get 8x cubed is equal to 1. So therefore, dividing both sides by 8, we get x cubed is equal to an eighth. Now, to get x on its own, we need to cube root both sides. The cube root of x cubed is simply x, and the cube root of 1 over 8 is a half. 2 times 2 times 2 is equal to 8. So therefore, x is equal to a half. So that's the first of our coordinates. To find the other coordinate, we need to substitute back into our original expression for y. So we get y is equal to 8. This will be a half squared, plus 2 divided by a half. Running out of space a bit, but this is equal to a half squared is 1 over 4, so this will be 8 over 4, which is 2. 2 divided by a half is the same as 2 multiplied by 2. So this second term will be plus 4, and that is equal to 6. Therefore, the turning point, TP, is equal to the x coordinate, which is a half, and the y coordinate, 6. And that is your answer.